Right. Thank you, Isaac. I'm very honored to be here at your astronomy club. I know that it can be a little difficult to start a new club. I actually am the former director of a club that I founded, the Utah Women Astronomical Society. So I'm very pleased to see new clubs popping up around the United States and globally. So today I will be talking to you about my expedition to the Atacama Desert and the implications and the infrastructure that the United States partners with global partners in the field of astronomy. And as you know, I'm a science educator and an amateur astronomer. So I am always open to learning more about astronomy from you all and the audience. So this is more of an interactive presentation. So I'm actually going to start with the end slide first. And so at the end of the presentation, I'd like us to kind of get to know some of your favorite experiences that you've had at other observatories. And if you haven't been to an observatory yet, if you could visit one anywhere in the world, where would it be and why? So as I'm talking about my experience with ALMA and the Atacama Desert, be thinking about your own experiences. And then at the end, we'll hear some great thoughts from you all. So I'm going to start with a map. So I am actually in Salt Lake City, Utah, and I flew down to Santiago, Chile. And Santiago, Chile is this long country over here. And this is zoomed in. So Santiago is where this black star is. And I traveled to La Serena to visit some of the telescopes there and up to northern Chile where the Atacama Desert where ALMA is located in the Atacama Desert. So this kind of gives you a reference of the location and the travel and the distance for this observatory. So my presentation actually encompasses two elements of astronomy. And the first element is the cultural perspective from the Atacaminos, or the indigenous population in Chile. And then the second element of astronomy, and the last part that I will be discussing, is a scientific perspective with the observatories, and specifically with ALMA, one of the largest array telescopes in the world. So when you look at the night sky, what do you see if you're able to see the night sky? You guys are doing a star party after this experience, or a sun party, solar party. What do you like to look at?
I'll start us off. I mean, my personal favorite is to see Jupiter. Whenever I can. I've gotten lucky once planning things just correctly where I can see the Great Red Spot. But otherwise, Jupiter is probably my favorite. Does anyone else in the room have a favorite object to see in the night sky? Pleiades? Yes.
So I love how you're repeating it so I can hear
Yes.
you.
So we were hearing from Colorado, being able to see a very crisp, dark sky, but oh, because there were so many stars, we couldn't see any constellations. There were just too many, which is, I think, a good problem to have.
Absolutely.
Milky Way? Corvus? Okay.
Very good. Excellent. Those were all wonderful objects to see in the night sky.
We heard
I know
exit
here,
as well.
I'm not quite sure in New Jersey, are you guys able to see a lot of night sky? I know folks from the East Coast complain there's a lot of light pollution over there.
You could see your typical Big Dipper, those types, but certainly nothing like the picture you have up on the screen.
Yeah. Well, if you ever come on over to Utah, we have some pretty good dark sky here. So it's similar to Colorado in certain parts of Utah. So yeah, very cool. Well, in the Atacama, the ancient indigenous looked at the night sky and they saw uh, constellations and the Milky Way, but they also saw the way of life. They saw calendars. They represented The stars in the constellation represented a compass and religious symbols. And there was also a spiritual dimension that we'll tap into a little bit in one of our slides in regards to the Milky Way. And as you can see here in this picture, and I give these cultural perspective information credit to Talia Modero, who was a former Alma tour guide, and she shared these with me. So here is the moon that they call Camor, and they based a lot of the moon phases, as you are well aware, on their calendar. And they consider the moon a female symbol, and it's considered the mother. And pregnancy calendars were also dictated by the moon from the ancient Atacamanos indigenous people. And then this is one aspect of their calendar that they used to understand the months and the years. And then here is the Milky Way galaxy from the perspective of the Atacamanos. And here you see that they consider the Milky Way galaxy the river of the spiritual world. And the Oscarana were the people that stayed on the planet, the humans that haven't passed on yet. And here, the Milky Way galaxy was considered a bridge or a gateway to their ancestors. And they, during November, they still do this actually, the indigenous folks, they actually use the Milky Way galaxy to know when to harvest and herd and to celebrate. So unlike the Greek cosmovision, where the stars are grouped to form constellations, the Atacamanos distinguish dark areas within the Milky Way galaxy. So they imagined various silhouettes, such as a mother llama and her baby. They imagined a frog, a fox, and a quail, and even a herder, a shepherd. During the late autumn, when the Milky Way is low on the horizon, as you see here in this slide, the indigenous people view the low Milky Way as a bridge to connect with their ancestors. As family members burn offerings for those who pass before them, the ancestors actually use this Milky Way as a bridge to walk on Earth and receive those offerings. So that's a very interesting perspective of how the cosmos is viewed culturally with the Atacamanos and the Atacama Desert. And it's very important that we respect their cultural perspective, because it enhances our understanding of astronomy and the multiple perspectives of the stars that belong to the human family globally. So this is one quote that I really appreciate is, "We used to sleep looking at the stars with a wool blanket. My father, who was a wise old man, used to say that there was a river in the sky and it was useful there, and in the other side where you go after you die." So it's just a very beautiful poetic sentiment when you're looking at the Milky Way. And here, this is La Yacana. This is one of the indicators for their calendar. They based this dark cloud to determine when it was time to harvest. So if they could see this particular shape, they knew what season it was, which would be September, October area. Now I'm going to have a challenge for you. Are you able to determine which shape this dark cloud represents? Does it represent, I'll give you a hint, I'll give you some options. Does it represent a fox, a quail, frog, or a llama?
Any guesses? Oh, we're guessing llama because it's in the title.
Very good. That indicates to me that I haven't bored you yet with my presentation, so that's wonderful. I'm glad you can notice my little hint up there. Yes, it is a llama. And I will show the next slide to outline that shape for you here. This is Alpha, let's see, Alpha Centauri and, or this is Alpha Centauri and Beta Centauri, I believe. And those two stars make up the eyes of the mama llama, and the head and the neck and the body. And I believe the baby llama is down over here when we look at a larger picture of the Milky Way galaxy. So these are some of the harvests that the Atacaminos utilized as they were using the sky, the night sky, as a calendar, as a compass, as a way of life, basically. It was their, I guess you could say, it was their Google back in ancient times. And so this just, it gives you some perspective of the food that they ate, some of the materials that they used, and it was all dictated by the night sky. Here in the right upper corner, you can see the calendar that they used to help them understand seasons and day and hour. And here you see the llama as one of their symbols. And this is a wider view of the Milky Way. And here is the llama that I showed in the previous slide. And here is the baby llama that is very distinctly seen in the Atacama Desert. So when you go out there, you can see these very dark bands of clouds. And in fact, they do look similar to the shapes that the Atacaminos saw. This is a reflection of the Milky Way galaxy. And this is the herdsman that they saw in the Milky Way. This is the fox, the llamas. This is the quail. And this is the frog that they utilized in their culture. This is actually a reflecting pool that they used. This is full of water. And you can actually see the constellations in these reflecting pools. So we were able to see, I believe, what was it? I believe it was the Big Dipper and another constellation, but I forget. And because the Atacama isn't distinctly south, you can actually see northern constellations and southern constellations at the same time. So we were able to see the Southern Cross and Hercules, and that was a very wonderful experience to kind of be in two hemispheres at once. So now we're going to bridge the gap between the cultural perspective of astronomy and the scientific perspective of astronomy. So here, this is a photo that one of my friends took. It's a composite photo of the Milky Way in the Atacama Desert and the sunset in the Atacama Desert. And here you can see him walking on a platform that is similar to a bridge. And that's one of the goals of the scientific community, is to bridge that separation that has existed for many hundreds of years between scientific knowledge and cultural knowledge. And recently, the science community has attempted to respect the indigenous cultures while still conducting science. There's still significant work yet to be done, but there is small steps in order to bridge those gaps. So why should we, the question really is, why do we want to do astronomy in Chile? And why has the United States put billions of dollars into the infrastructure? And one of those reasons is because the Atacama Desert is the driest non-polar region in the world. So the Antarctica is a desert, but it's drier than Atacama, but it's a polar desert. So it's clear, and the skies in the Atacama Desert are clear for more than 300 days out of the year. 70% of the world's telescopes are actually located in Chile, And most infrastructure installed to investigate the universe is optical, infrared, submillimeter, and radio wavelengths. And the National Science Foundation, in partnership with the Department of Energy, has jointly invested more than $1 billion in astronomy in Chile. So it's very important that we are aware of these opportunities and observatories, because we are a part of that investment. So let's see. So after we landed in Santiago, we flew to La Serena and drove to Cerro Tololo, which is a mountain range in the Andes. And Cerro Tololo is also the name of the observatories that we visited. As you can see here, there is the SOAR telescope, the Southern Astrophysical Research Telescope. And this particular telescope observes the universe with visible light and infrared wavelengths. This telescope is 4.1 meter in diameter, and it's a reflector telescope. So here's an example of SOAR's capabilities. And here you see a young brown dark dwarf star extending jets of ionized gases out. And this is 0.7 light years long. Now, what's really interesting is that these young brown dwarf stars are more readily are more numerous than there are sun-like stars in our universe. So our star is a yellow dwarf, a medium yellow dwarf, depending on which articles you read about the sun. And there's more brown dwarf stars than our type of sun in what we've discovered so far. It's very interesting. This is actually the first jet of gases seen in a brown dwarf star, because they're not very powerful. There's not a lot of gases that they consume. But this result lends new insight into how substellar objects form. On the same mountain range, we have Gemini South. And Gemini South is identical to Gemini North, which is actually located in Hawaii. Gemini North has an 8.1 meter mirror, and it's another optical infrared telescope, and it studies all fields of astronomy. So for example, in this image, it's depicting the reflection nebula GGD 27, and it's revealing the chaotic and messy environment of a stellar nursery. And this is a near infrared image. Although it does look messy and chaotic, kind of like some of your teenage boys or girls' rooms, scientists predict that in millions of years, these gases will dissipate, displaying a cluster of stars similar to a butterfly emerging from its chrysalis. So it not only do these telescopes help us understand the scientific aspects, but it also depicts the beautiful elements that are out and about surrounding us in the universe. Here, finally, is Rubin, and Rubin is the world's largest digital camera with 32 megapixels. It will take pictures of the entire night sky every few nights, and its first light is expected next month. After we traveled to the SOAR, Gemini, and Rubin telescopes, we drove about 30 miles to another point in Cerro Tololo, to the Blanco telescope. Before I talk about the Blanco telescope, I wanted to reveal to you what Cerro Tololo means from the indigenous culture. And Cerro Tololo actually means the abyss. So it seems very appropriate that these telescopes are studying the abyss of space exploration. It's as if the indigenous could predict what the future would have for these mountain tops. The Blanco telescope is 4 meters or 13 feet in diameter. It observes and studies many aspects of astronomy, such as this galaxy here on the upper left hand. And this is probably one of my favorite galaxies. It's called the Gentle Giant galaxy, and it's 75 million light years away in the Sculptor constellation. And here is the view. They opened up the dome to the Blanco telescope here. And this video, let me see if I can move over. This video will show you the view from that, how high we were. All the sound is wind, so I'm just going to keep it muted. These other telescopes are a global partnership with Japan, with the United States and things. And then here you see the Andes Mountains in the background. All right, so as we finished up Cerro Tololo, we flew more north, as I mentioned, to San Pedro de Atacama. This is the driest non-polar desert in the world, and it has a humidity of about 10 to 20%. And that is because we built Alma in these dry conditions because radio waves act like similar to microwaves. When you heat up a soup in a microwave, those microwaves are interfering with those water droplets and causing it to vibrate. So when radio waves come through the atmosphere, we don't want those water particles to interfere with the information from those radio waves. Otherwise, the images will be blurry or the data will have aberrations in it. So it needs to be very dry for those radio waves to lessen that interference of the information that they're trying to gather. So small communities live within this region. We passed a couple of those villages, and they range in feet from 7,900 feet to 13,000 feet. In Utah, our tallest peak, I believe, is 9,000, and we're a pretty mountainous range, but Atacama is much higher than even the Rocky Mountains, at least in Utah. I don't know about Colorado. Here we see some of the views in the Atacama Desert. Even though it's very dry, surprisingly, there is still vegetation. It's just very small in size, as you can imagine. And these are actually the precursor, the original llama. These are called vicuñas, and they are strewn all about the a mountainous region in the Atacama. So it was very surprising to see that, yes, indeed, the Atacama is a very active biological habitat. Finally, we reach ALMA, and this is ALMA stands for the Atacama Large Submillimeter Array Telescope. And this is me sitting on the L before the authorities came and kicked us out. So this was a very fortunate picture that we got. And as you can see here in the background, very dry salt lake beds, very flat. However, don't let that deceive you, because just to the west of me was a very tall mountain that has the ALMA antennas at 16,500 feet. So here you can see the complex data that is being gathered from the astronomer and the operator. So they always have at least two people in the room understanding the data and collecting and gathering that data. They also have a lot of engineers, a lot of cafeteria workers, and a lot of plumbers, electricians that work on site to keep this facility working 24/7. Here we are at Jinjanchor Plateau, which is the location of the 66 array telescope. These radio antennae act as one large receiver. And coincidentally, ALMA, these telescopes here, study the same dark regions that the Atacaminos observed for thousands of years. These dark regions are very cold and emit large radio waves that ALMA uses to transfer into images and data. So for example, ALMA studies the formation of stars and planet formations. This is actually a red giant star that ALMA was able to capture. And as you can see, these are unexpected spirals that are around the old star, this old red giant, which is in this area here. Scientists think that this spiral is probably caused by a hidden companion star that's orbiting our Sculpturus. This star is 8 times the mass of the sun, and interestingly enough, the morphology of this red giant with companion stars is actually quite common. So when you have a multiple star system, you see these beautiful spirals caused by the companion star. Now, the 66 antenna are reconfigured in certain times of the year to collect different types of data that the astronomers are trying to collect. Now you can imagine it is quite a task to move these very large antenna. And so these two trucks or mobile devices are custom made for ALMA. In fact, they created the road specifically for these transportation devices. And one is called Otto and one is called Lori, and they were made in Germany. So I have a short video to show you their capabilities of how they move these antennae. So if you notice on this platform here in the foreground, you can see the 2, 3, many different types of plugs, many different types of supporters to keep them in place. As you can imagine, this video is sped up quite significantly, but in real life, it takes almost all day to move one antenna because they move so slowly and so meticulously as to not ruin any of the sensitive electronics and temperature that needs to stay stable in order for these antennae to work properly. I was actually able to see them move one of these antennae in real life. And here you can see the engineers, and they use a remote control like in a Nintendo game. It's strapped to the guy's front area, and he uses a joystick to move the antenna in place and to create this amazing experience. So that's how they move those antennae around. After they moved the antenna around, the engineers decided to have a little bit of fun. And so they passed the joystick to each one of us I have to say I was quite nervous to hold this device, but it was a wonderful photo opportunity, and the antenna did survive my grasp of the controls, so I didn't ruin anything, which I'm very proud of. As you can see in this picture, we do have to wear oxygen because the altitude is very high. We also had to wear bucket hats because the UV is very strong in that high elevation. So you want to wear a lot of sunscreen and oxygen. Interestingly, we had to do a physical exam before we went up to 16,500 feet just to make sure that our blood pressure wasn't too high. It's similar to a Mount Everest climber where you have to acclimatize to your environment for a couple of days. That's what we had to do when we went to Jinjanchor. There's a base camp a couple miles down that we stayed for a day or two. They also recommend not to drink coffee or drink any alcoholic beverages the night before. And I will tell you that some of my companions became quite different personalities when they were not able to have their morning cup of coffee or their nightly little spiritual ritual with their alcoholic beverages. This is the team that I went with. We all over the world. It was a global collaboration. I am right here, right behind her with my bucket hat. And as you can see here, this is a very beautiful mural that they painted with the satellites, including ALMA and the star system here. And I was able to capture the Milky Way galaxy using my astrophotographhy skills and my Nikon D750 and a little bit of editing, but not much. So this is a beautiful depiction of the Milky Way galaxy in the Atacama Desert. So ALMA, Blanco, Gemini, SOAR, and many more telescopes continue to fascinate us with their images and discoveries about our cosmic origins. Similar to the Atacaminos, we peer into the cosmos, asking the same questions that they did thousands of years ago, which are who are we? Where do we come from? And as the wise Atacama's elders humbly explained, for without the sky, there would be no earth. There would be no us. And that is the end of my presentation. And that is the end of my experience in the Atacama Desert with ALMA and those telescopes. And I would love to hear some of your experiences and any questions that you might have. And Isaac, if you don't mind repeating what they say through the mic so I can hear it, that would be great.
What type of data are they collecting, and are they looking for ETs?
These particular observatories are not equipped for extraterrestrial life. The one in Puerto Rico, what was it?
Arecibo.
Yes, that one was equipped for artificial intelligence. These telescopes are picking up radio waves, which are the larger wavelengths of data. And so they're mostly looking at cold regions of the Milky Way galaxy, not necessarily exoplanets or possible forms of life from other planets. Those would require different types of telescopes, not radio waves. Although I wouldn't discount it, perhaps ETs communicate through radio waves.
If I remember correctly, one of the interesting stars in the southern hemisphere is Canopus, I think. Were you able to see that? Canopus?
Oh, let's see. I went in August of last year on this expedition, and I cannot recall if I did see that particular constellation, but I did see the small and large Magellanic clouds, and they can be visible without any sort of aid. You can see it with the bare eyes. Alpha Centauri, let's see, Omega Centauri, the Southern Cross. Those were some notable southern constellations. Sculptress. I believe we even saw Corvus, but not quite. I can't quite remember if we saw that one.
That's in the northern, that's near the close to Virgo, Corvus, not in the southern one actually. Anyways, I just want to make a comment on the cultural aspect. I was born in India. Everything that runs there is based on astrology. Even the Prime Minister of India, the President of India, assume office on a particular day at a particular time, dictated by astrology. That means where moon is, where sun is, where the planets are, what star. I mean, each day is assigned one star. There are 27 stars that are identified as most important stars. They are said to be the wives of moon. And the months are also designated by the name of the star. In the month full moon day, whichever star is close to moon in that month is called by that star's name. Yeah, like that we have. And it's a big business actually. The astrology is a huge business. It's kind of a $2 billion business that comes to in the US. You can call it about, $100 billion business. You can say everything runs on the basis of astrology. Horoscopes, weddings, matches are fixed based on astrology. Whether the two horoscopes match or not, it's all based on the thing. Very, very interesting. Yeah, thank you.
Yeah, that is very interesting. Thank you for sharing that with us. Astrology and astronomy historically were quite similar. However, through time, as you can imagine, they have separated quite distinctly in their fields of information and data and things of that nature. But I really appreciate that cultural aspect that you put in your home country. Very fascinating. Astrotourism is a big business in Chile. In fact, we visited a high school in San Pedro, and they were learning about astrotourism, because a lot of professional astronomers and amateur astronomers go to the Atacama Desert because it's prime real estate for astronomy. So yeah, that's very interesting.
It's funny, while I was listening and watching your presentation, I was actually planning a couple trips myself.
Yeah, so you're a solar system ambassador, right?
Yes.
So the program that I belong to is called the Astronomy in Chile Educators Program, and a lot of solar system ambassadors apply to that expedition and get in. So if you're interested in how to apply and any references you might need, I can certainly help you with that in order for you to experience this similar expedition.
I would love to learn more. Did you have a question?
A couple of questions. So the first one is that for that kind of expedition, I mean, do you have to be like an ambassador of some kind to go, or is it open to tourists? That's one. The second one is that you mentioned earlier that the locals use the galaxy to predict when is the right time to do their agricultural activity. Is that kind of a later supported by science, or that's just a tradition? That's all. Thanks.
So let me address your first question. So in order to apply for this particular expedition, they are looking for planetarium educators. They're looking for K through 12 educators, and they're looking for more informal astronomy educators for this program because they want you to disseminate and do outreach activities to help bring the community to awareness of what astronomy is doing in Chile. As a tourist, it would, if you could bring in some good informal education strategies and a good informal education plan and apply to the program, then your chances are much better than if you're going to go as a tourist. This program is funded by the National Science Foundation and NORLab, which is heavily emphasized with astronomy education. And then your second question. Can you repeat your second question, please?
Sure. So earlier in your presentation that you mentioned the locals use the galaxy phase and everything to predict the agricultural activity, like when is the good time for harvest. Is that later supported by any scientific evidence that they were actually doing the right thing, or it's just like a tradition? That's all. Thanks.
Oh, yes. Thank you for repeating your question. I think certain aspects of the calendar were scientifically accurate. I would have to dig deeper in order to give you a more full answer of yes, they were scientifically correct in their traditions. I imagine, though, the traditions of predicting the moon phases and understanding the calendar would not deviate too much from the scientific aspects of seasons, day and night, and when it's time to plant and when it's time to harvest. But I would have to dig deeper in order to give you a satisfactory answer. Good question.
Yes. Earlier you mentioned that they've been looking into galaxies that are like far away from ours. Have they also been looking into how to get to say galaxies, like how to travel through like light speed or any way to increase travel in order for us to reach said locations to research them more? Or is that for another observatory to study?
You know, that's a wonderful question because space travel is always on the forefront of the minds of many engineers and space explorers and things of that nature. In this regard to the purpose of the observatories, this is more scientific of how planets form, how stars die, how stars are born, how planets and solar systems coalesce and create new environments in space. I wouldn't say that their first priority is understanding space travel. Their first priority is more understanding the universe and how it's made and how it interacts with other stars and things. These observatories, again, are focusing on the dark, cold, very, very distant areas in our Milky Way galaxy. And so, for example, the Gentle Giant galaxy is 75 million light years away, and 1 light year is 6 trillion miles. And light travels at about 186,000 miles per second, I believe. Someone might have to fact check me on that. So they're studying very, very distant objects. So I'm not sure if space travel is something possible with this study, but it is. I'm sure other scientists and observatories are studying space exploration.
One last question.
Sure.
There's another like theory I've always thought of since it's shown in a lot of movies and media. The multiverse. Could it be possible with these observatories to find out if there are multiple universes rather than the one universe we are currently in?
That's a really, that's a, I love that creative question. And again, that would enter into quantum physics.
Oh, okay.
So I so there's actually a great scientist that I would recommend because he discusses multiverse, and perhaps you've heard of him if you are asking questions about the megaverse and other universes beyond our own, and that is Brian Greene. He did The Elegant Universe. He wrote a book and then he did a PBS special on that. And I would highly recommend you check him out and the information that he has on that megaverse theory and string theory, which is tied to that megaverse ideology. I'm not sure if these observatories have that capacity. Uh, there's always limitations to an observatory. They're mostly infrared optical observatories. So I would imagine that they're limited in discovering a parallel universe of some kind. Great question, though. Brian Greene.
Thank you.
I would highly suggest look him up.
Okay, two questions. The easy one first. As an astrophotographer, what is your favorite object to photograph in the night sky? And then the somewhat harder one, as we keep building bigger and more sophisticated telescopes, we keep being able to observe objects that are further and further away, and thus the light started out much further back in time. Is there a limit to how far back in time or how far away we could observe?
Okay, so your first question is definitely the easier one of the two. I'll certainly start with that one. I would say that with my astrophotography skills and experiences, I mean, there's many dark sky objects to capture and observe. I love the Witch Head Nebula, the Shark Nebula, the Rosette Nebula that you could photograph. But I always go back to the Milky Way galaxy. That's just my ultimate. It's just so beautiful. I just can't stop taking pictures of it. So I would say definitely the Milky Way. And then the second question is there a limit to how far we can see in the universe? So I am not sure how familiar you are with the James Webb Space Telescope, which is in Lagrange point 2, which is 1,000,000 miles from Earth. And it is a space telescope. So it's not a radio telescope. Radio telescopes are highly limited. But this particular telescope, similar to Hubble, can see at least 13 billion years in the past. And according to scientists, the universe is at least 13.8, perhaps 14. They had a new number come out recently, so it's always changing. So James Webb can see very, very far into the past because it has this intense infrared capability to collect data from these very distant red wavelength early galaxy systems. So as far as I'm concerned, the more we build, the bigger the telescopes and the farther we place them out into the solar system, we will be able to see some that's the beauty of astronomy, is that we have the more we explore, the more questions seem to develop in the way that these telescopes are giving us data and these beautiful pictures.
Does anyone have any observatories that they've visited? Any favorite ones or ones that they want to visit?
So the coolest observatory that I've been to is one of the more historic ones in the city of New Brunswick on the campus of Rutgers University is the Schenck Observatory, which is one of the earliest observatories in North America. normally it's closed to people, but if you go up there on Rutgers Day, they open the observatory for tours, and one of the university scholarly organizations has actually restored it and the telescope in it. It's not ready to actually be used for optical viewing, but it probably will be by next year's Rutgers Day. I don't know if they plan to open it for actual star viewing, but at the very least you can go up into the rotunda and see the restored telescope and the facility. And if I could go to any particular observatory, unfortunately I'd need a time machine, because I would have loved to have been able to go to Arecibo when it was actually in operation, because my other hobby, in addition to astrophotography, is I'm an amateur radio operator, and that's like a blending of my two favorite worlds.
Oh yeah, that's fantastic. Have you heard if they're going to build a similar form of Arecibo?
So the last thing I heard was they were going to try and build an array, but the challenge that they have to overcome is synchronization of data. It's a serious challenge in optical telescopes, but also in radio telescopes. The amount of data that they gather, even the fastest computer interconnects are not enough to actually synchronize the observations of multiple instruments at once. Our timing is not precise enough to handle the transmission of that data. Because there's so much of it, it has to be very precise in time. And at best right now, our most accurate clocks cannot synchronize computers closer than about 4 nanoseconds in accuracy. And that's not enough to actually stitch these observations together from multiple either radio telescopes or optical telescopes. In fact, there's one, I believe one of the sites that you visited has a very sophisticated analog system for merging visual observations. They use a series of mirrors. There are tunnels underneath the ground that contain very, very precisely laid out sort of rail tracks of mirrors. And they're extremely precisely aligned to get the delay correct, because as you mentioned, light moves extremely quickly, and trying to synchronously merge 7 or 8 streams of optical data is beyond our current computing capacity.
Right, and even those 66 antenna at Chinchontor, they act as a 10-mile receiver, and so collecting all that data, everything has to be very precise. The weather has to be perfect. Everything has to work. It's almost like a domino effect, if you will, with all that information.
The dark cloud that you mentioned at the beginning that they use for harvesting and stuff, how large is that compared to a constellation like the Big Dipper or something? Or is that something pretty small?
The llama, the dark clouds are rather large in the night sky. I would say, although the Big Dipper itself is, I mean, it's not bigger than Ursa Major, but if you look at the asterism, the Big Dipper, then it would be similar in size. The Big Dipper might be a little bit bigger than the dark cloud of the Llama, which is the largest portion of that Milky Way darkness. But yeah, the constellation Ursa Major would be larger than the dark cloud in the Milky Way. Great question.
Thank you.
Anyone else? Great. Well, if there are no more questions, Emily, thank you so much. When I reached out to our Solar System Ambassador Facebook group looking for presenters for the club, I'm so glad that you stepped up and volunteered to do so. So thank you. Thank you so much for your presentation and for your time.
My pleasure. Thank you.